Hi friends, I'm your hope, you're my hope. I'm Nadira. Today we will learn about perimeter of segment. First of all, I will introduce you to some of the formula that we will use in this subtopic. First, the formula of converting angle to radians. Second is the formula of finding the arc length, which is S equals to R theta. Last is the formula of cosine rule, which you have learned in Form 4.
Next, we will see the examples for this subtopic, which is the perimeter of circle. Example 1. The question is, for each of the following with center O, find the perimeter in cm of the shaded segment A or B. Okay, first of all, we need to use the cosine rule in order to get the length of AB. So from here, you just need to substitute the value into the formula. So we will get AB square equals to 8 square plus 8 square minus 2 times 8 times 8 cos 35, which is the angle. Next, press your calculator and we will get 4.881 cm, which is the length of AB. Okay, in order to find the arc of AB, we need to use the formula S equals to R theta. We have the value of radius and we already have the value of theta. So we just substitute the value. Don't forget to change your angle into radian by multiplying it with pi over 180. Then we will get 4.888 cm, which is the length of arc AB. And the last step is we need to add both of the value, which is the length of AB and arc of AB. So the perimeter is 9.699 cm. Now let's look to example number 2. The diagram below shows a circle with a center O and a radius of 10 cm. The chord AC subtends an angle of 114 degree at the center of the circle. Calculate the perimeter of the shaded segment ABC. Use pi equals to 3.142. First of all, we need to change the degree into rad by multiplying it with pi over 180. So we will get 1.990 rad. Okay, so if we look overall, in order to find the perimeter of the shaded region, okay, we need to find the length of AC and the arc of ABC. Let's find the arc of ABC first. So we need to use the formula S equals to R theta. So we will get 19.90 cm for the length of arc ABC. Okay, then we need to find the length of AC by using the cosine rule. So we just need to substitute the value into the formula of cosine rule. And by pressing your calculator, we'll get the answer, which is 16.773 cm. So the last step is we need to add the length of AC with the arc of ABC. And we will get 36.673 cm. Move on to the last example, which is example 3. So same goes to this question. Okay, we need to find the perimeter of the shaded segment. Okay, so as you can see, the shaded segment is ABC. So the same thing, we need to find the length of AC and the arc of ABC by using the same formula. So find the arc of ABC first by using S equals to R theta, and then substitute the value of radius and theta. So here, as you can see, the angle which is given is pi over 3 rad. At this question, we need to use pi equals to 3.142. Okay, so just multiply it with 10. So we will get 10.47 cm. Next step, before we calculate the length of AC, don't forget we need to change the rad into angle first, because the cosine rule will need to use the angle, not rad. Okay, so simple, we just need to multiply it with 180 over pi and we get 60 degree. So just substitute it into the formula. Okay, press your calculator. So the answer is 10 cm for length AC. Lastly, you need to add both of the values, so you will get 20.47 cm. Don't forget to write the unit. Okay, so just a reminder, okay, if you want to calculate the value of the cosine rule, okay, by the equation, okay, make sure you press the calculator one by one, okay, you calculate it one by one so that the calculator won't be confused and to avoid you from getting the wrong answer.
Example 1. The diagram on the right shows a circle with center O and a radius of 10 cm. The chord AC subtends an angle of 114 degrees at the center of the circle. Calculate the perimeter of the shaded segment ABC. First of all, convert 114 degrees into radians. So, if you calculate 114 degrees times pi over 180 degrees, you will get 1.990 rad. Step 2. Find the arc length of ABC using the formula S equals to r theta. Substitute the value of r and theta given to get the answer, which is 19.9 cm. Step 3. By using the cosine rule, which we have learned in Form 4, find the length of chord AC. Substitute all the value and you will get AC equals to 16.77 cm. Lastly, sum up the length of chord AC and arc length ABC to get the perimeter. So, if you press your calculator, 19.90 plus 16.77, you will get the answer 36.67 cm. So, that is the value of the perimeter of the shaded segment ABC. Example 2. The diagram on the right shows the region for the shot put event drawn on a school field. The region is made up of two sectors from two circles AOB and POQ, both with center O. Given that angle AOB equals to angle POQ equals to 50 degrees, OA equals to 2 meter, and AP equals to 8 meter. Calculate the perimeter of the colored region ABQP in meter. The first step is you have to convert 50 degrees into radian. So if you calculate 50 degrees times 3.12 over 180 degrees, you will get 0.873 rad. Step 2. Calculate the arc length of AB using the formula S equals to r theta. Substitute all the value that you gain from the information given to find the arc length. So, if you press the calculator, you will get 1.746 meter. Step 3. Find the arc length of PQ using the same formula S equals to r theta. If you substitute the r, which is 10, and theta 0.873, you will get the answer 8.73 meter. Lastly, step number 4, you have to sum up arc length AB, the length of BQ, arc length of PQ, and the length of AP. So you will get an equation which is 1.746 plus 8 plus 8.73 plus 8. And then if you sum up all the value in the equation, you will get 26.48 meter, which is the perimeter of the shaded region ABQP.